So I want to give a quick introduction into these types of problems. They look really complicated. They're not too bad, and you can essentially kind of memorize a little bit of a couple things to think about and know what you're doing. And so after we go through this here in this video, if you feel like you need a little bit more, there's extra videos that I've laid out there and some other notes and stuff for you to look at, but maybe this will be enough. Okay, so we've got this formula here, all right, and it's our definite integral that we know very well from a to b of f of x dx. And then it's got this limit as n approaches infinity of the sum from k equals 1 to n of f of a plus k delta x times delta x. Oh my gosh, there's so much there. Okay, so let's what in the world is that? So basically, we did Riemann sums where we, if you remember, made rectangles. These are some great rectangles, and estimated area under a curve using rectangles. All right, that was called a Riemann sum. Essentially what this formula here does on the right is we're taking that Riemann sum, all right, and we're going to let n, which is the number of rectangles, go to infinity, right? So we're going to take all those rectangles, we're going to shrink them down until we get an infinite number of rectangles, okay, and here's a to b, that will give us the exact area if we do that limit, okay, of the number of rectangles. So the first thing you have to recognize here is that this is the height of a rectangle, and delta x is, of course, the width of a rectangle. And if we do height times width, that's area. So this is saying, and this notation, you do need to know that. If you don't, you gotta watch one of those other videos here below this. That's a sum. It means we're gonna add up all of the rectangles from 1 to n. So if we had like 10 there, we'd add up 10 rectangles, 1 to 10. But if n is we're letting n go to infinity, we're adding up an infinite number of areas of rectangles, and that gives us the area under the curve from a to b. And so that's why this right side is actually equal to the left side. Okay, so how do we turn this into a really easy problem to do? We know that delta x is the width of a rectangle. Oops. And if delta x is the width of the rectangle, I know that each rectangle would have to be the whole amount of distance I'm covering divided by how many rectangles there are. Well, that whole distance is b minus a. And how many rectangles are there? Well, we're going to make n rectangles. So delta x is really b minus a over n. Okay? And that b minus a is still our overall width of the interval, a to b. Okay. The other thing I want to point out, this height of the rectangle is taking a, which is our first x value, and adding a little bit times the width of the rectangle. Okay, k is counting up our rectangles, so k starts as 1. So at the very beginning, we'd have a plus 1 delta x. That means the first rectangle, right? And so it's giving us this height right there. Whatever a plus delta x is the x value. So, and I feel like I'm kind of been building up to something that maybe you haven't seen yet. That a value there is the same a value as the beginning bound on our integral. And b minus a is the same value as you would get if you did those bounds on our integral subtracted, b minus a. So when we look at a problem like number 1, number 1's giving us the right side of the equation. So our job is going to be to write the integral that this represents. So we're thinking that we're going to end up with integral from sum a to sum b of some function dx. And it's going to be my job to figure out that function and the a and the b, right? Well, the first thing to remember is that that a and the b shows up in the delta x, which is right here, right? I now know, just by looking at that the a minus b is 3. A minus b, oh, I said that backwards. B minus a is 3. Sorry, b minus a is going to equal 3. So I know the width is 3. The other thing we are going to look for is this kind of beginning value of a. Where are we starting? So the way you do that is you try to figure out what f of x is. And so I know that the thing multiplied by delta x is my function plugged in, with something plugged in here, right? So I gotta kind of think, what is this function right here? And it really, to me, looks like x squared minus 1. So the place that I would be plugging in there is the x. And so, did I have a starting value, like the a plus k delta x, or did I just end up with k delta x? And you can see I just have k delta x there. So delta x is the 3 over n, k delta x right there. So there's no, it's like 0. It's almost like I have 0 plus k delta x, right? Which means my a value, my beginning, is 0. So I'm going to then take this as the integral from 0, and I know my width is 3, so 0 to 3, of the function that I found, x squared minus 1 dx. And that is your answer to number 1. I also want to do one where we're going the other direction. So let's look at number 10. So I have the integral from 2 to 4 of 3x squared minus 1 dx. So I need to have a limit as n approaches infinity of the sum from k equals 1 to n. And then I remember I have that kind of f of, and I have the delta x, the width. Right? So to write the width, it's b minus a over n. b minus a is 4 minus 2. So I'm going to get 2 over n just by looking at the 2 and the 4. I also know that I'm starting at 2. So when I plug in the a plus k delta x, I know a already, it's 2. So it's going to be, I'm going to kind of write this off to the side, f of 2 plus, k is literally going to be in the answer, and delta x I already know is 2 over n. And since I already have my function, 3x squared minus 1, I can just plug that in. So it's going to be 3 times 2 plus k times 2 over n, so you might see it as 2k over n squared minus 1 times that 2 over n. So this is our final answer here. Okay, so kind of to summarize here, it's really about two different things. It's about this number here, which is the total width of the integral, our interval that we're doing the integral of. And then kind of looking for this a value here plugged into our function. All right, that tells you where to start. So if you feel like you want to try a few of these out, go for it. If you need a little bit more, I've got those other videos listed below this one to dig in a little bit deeper on these. Thanks for watching.